Okay, so isosceles and equilateral triangles, as I said, a lot of this is review, which is nice. An isosceles triangle has at least two congruent sides, as you know. And then here's some vocabulary associated with isosceles triangles, starting with the legs of an isosceles triangle. The two legs are the two congruent sides, so they are the same measure. And then the angles opposite those legs are called base angles, and the base angles are congruent. So base angles right here. Then we have the base of the triangle, which is right here. It's the side that's not the same as the other two. And then vertex angle is this top part right here, vertex angle. And this is the angle that's not the same as the others. So these two angles will be the same measure, and then this one will be different. But the three angles will still add to 180, and you can use that to figure out the angles if needed. Okay, then we have the base angle theorem and converse of base angle theorem. What this says is if you have two congruent sides, then your base angles are also congruent. Or your base angles here are congruent, then your legs of the triangle are congruent. They called this base angle theorem or converse of base angle theorem. I've also seen it called isosceles triangle theorem. If you know your vocabulary, whatever shows up on whatever test you're taking, you'll be able to figure it out. Okay, then name the congruent parts of each triangle. Here it shows that this side is equal to this side, so we can say that FD, segment FD, is congruent to ED, and the base angles right here are the angles opposite these sides, so we can say that angle F is equal to angle E. Okay, naming congruent parts, angle T is equal to angle W, and then the sides opposite those base angles will also be congruent. So this leg and this leg, segment TO, is congruent to segment WO. Okay, next. Up here, this gets a little bit more challenging. I'm going to write in pencil actually, so that way I can kind of erase as I go. Okay, so segment AE right here is equal to DE. Then which angles would be equal? So we got angle A and angle D. Okay, next one. If AB is congruent to EB, so AB is congruent to EB, which parts are equal? Well, it would be this angle and this angle, so we have angle A. And then this angle would be BEA. The reason why we only use one letter for this one and then three letters for this one is because angle A can only be this angle, but if I was to label this angle E, it could be this angle, or any combination of those angles, so I had to be more specific, and by saying BEA, it specifically refers to this one. Okay, next one. Angle D is equal to CED, this one. Well, if those two angles are equal, then this segment must equal this one. So CE would be equal to CD. And then EBC, just connecting the dots, this angle, and ECB. If those are equal, then this segment would equal this one. So EB would equal EC. Okay, next. Now we're going to bring in the numbers. Okay, so find the unknown measure in the triangle. this shows that we have an isosceles triangle, meaning that the base angles would be the same. So if this is 50 degrees, then this would be 50 degrees. And then to find that vertex angle, we are just going to subtract the two base angles and see what's left over. Comes out to 80 degrees, so our vertex angle is 80 degrees. Okay. Next, it shows that the base angles are the same, therefore it is isosceles and these two legs are the same measure. And if this is 5 centimeters, then this is 5 centimeters. Next, number C, these two legs are equal, so we got the base angles are equal. If this is 46 degrees, then this is 46 degrees. And then because it's a triangle, the three angles add up to 180. So we can do 180 minus 46, and whatever's left over will be the vertex angle, 88 degrees. Okay, D is where people get tripped up sometimes. The legs are the same, the base angles are the same. So what we're going to do is we're going to subtract the vertex angle from 180. 180 minus 40 equals 140 degrees. And then that 140 degrees has to be split evenly among these two angles. So 140 divided by 2 is 70 degrees. So 70 degrees. Okay, and then E shows that these two sides, then these are your base angles. If this is 63 degrees, then this is 63 degrees. We're going to subtract 63 and 63 again to find the vertex. And it comes out to 54 degrees. Okay, and then this one here, it says solve for x. It shows our base angles are equal. So then these legs are equal, and we can set these equal to solve for x. 3x plus 4 equals 22. And just solve. Next page. It actually gets easier for once instead of getting harder. Okay, next page is equilateral triangles. Equilateral triangles, as you know, all the sides are equal. For equilateral, all sides are equal. And then what you may have not considered is that means that all the angles are then equal. So here it shows a little visual. If all the sides are equal, then all your angles will be equal. And then all these angles add to 180. So if you do 180 divided by 3, you get 60 degrees. So in an equilateral triangle, the angles are always 60 degrees. Okay, so then looking at a couple examples based on that concept, find the measures of angle P, Q, and R. The three sides are the same length, so our angles are the same. 180 divided by 3 is 60 degrees, so the angles are all 60 degrees. Okay, for B, it shows that it's equiangular, all the angles are the same, meaning that all the sides are the same. It asks for the length of ST. It shows that UT is 5, so it must be 5 as well. ST equals 5. Cool. C, find the value of x and y. It shows that all the sides are the same, so therefore all your angles will be the same. They're all going to be 60 degrees. So you can set these expressions equal to 60 and solve. So y minus 10 equals 60, x plus 5 equals 60. Then I'm solving for the variables. Okay, and the next, oh, wait a second. Okay, now we have a couple word problems. A little bit more work, but I'll make them seem easy. So the measure of each of the congruent angles in an isosceles triangle is 6 less than the measure of the vertex angle. So I'm going to draw a isosceles triangle. The measure of each of the congruent angles, so that would be the base angles, is 6 less than the measure of the vertex angle. So x minus 6 for each of these, and then this would be x. Okay, well, to find out what x is, these three angles have to add to 180. So I'm just going to do x plus x minus 6 plus x minus 6 equals 180. And then we can solve for x. Combine like terms. We get x equals 64. But the problem doesn't ask for what x is, it asks to find the measure of each angle of the triangle. So once I have x, I need to plug it back in. So this would be 64 degrees. 64 minus 6 would be 58 degrees. Again, 64 minus 6 would be 58 degrees here. And then the next one is same style of problem. The measure of the vertex angle of an isosceles triangle. So I'm drawing my isosceles triangle. The vertex angle is 15 more than the measure of each base angle. So the base angles are x, and then this vertex angle is x plus 15. Find the degree measure of each angle in the triangle. Okay, so x plus 15, the vertex angle, plus the two base angles is 180. Combine like terms, 3x plus 15. And then once I get x, I do need to plug it back in to get 55 degrees, 55 degrees, and then 55 plus 15, which is 70 degrees. That's all. So now you can get a laptop, get your homework started. Once your homework's done, work on Alex. If you have 8 Alex done, you can ask to get your phone. Let me know if you have questions. And yeah.